Welcome back to Maths with Mrs. J. We've been learning about differentiation. With a sum or difference, it's okay just to differentiate each bit and then add or subtract the derivatives. If you have a product or a quotient, however, you cannot just differentiate each bit and then multiply or divide. There are special rules for those cases. Now, a slight issue is that in order to teach the product rule, I'm going to use examples that normally I wouldn't use the product rule for. Let me just explain that to you. This here, y equals x squared plus 5, 3x minus 2. Rather than using your product rule, you would be way better off just expanding and then differentiating. However, because we've got a few rules that we haven't yet learned, I can't do anything more complicated than this to teach you how to do the product rule. So just bear with me. I promise it'll all make sense in the end. Okay. I'm going to use some colours here to help us, and I'm going to explain what the rule is. The rule says if y equals uv. So that means if you've got some function that is a product of two functions. I'm calling v, the purple one, and u, the orange one, okay? Then dy dx is going to be u times dv dx plus v times du dx. Now that sounds all very complicated and awful and horrible. Let me go through it with that setting out first, and then I'll show you how you do it in practice. All right? Normally I wouldn't set it out in full like that, but let's do it. So let's say, let u be x squared plus 5. So what's du dx? Du dx is the derivative of this, which is 2x. And let v be 3x minus 2. So dv dx is 3. Now our rule, let's write our rule down. Dy dx equals u dv dx plus v du dx. Okay, so u is x squared plus 5, dv dx is 3. V is 3x minus 2, du dx is 2x. Now I'm going to expand and simplify, so I'm going to get 3x squared plus 15 plus 6x squared minus 4x. So you're going to end up with negative 3x squared minus 4x plus 15. Now let me just stress, with something like this that's easy to expand, you are way better off expanding and then factorising, because look, we ended up having to expand down here anyway, all right? But this was just to demonstrate how you do the rule. Now this is very unmathematical the way I explain it, but just bear with me here. The way I think of the rule is this. It's first thing times derivative of second thing plus second thing times derivative of first thing. And that's how I remember it. It's very unmathematical, and we just write down product rule. Let me show you how I would set this one out. I wouldn't do all this stuff with the let u and let v. I would just say dy dx equals first thing times derivative of second thing, which is negative 1, plus second thing times derivative of first thing, which is 4x plus 3. Now, because I haven't shown all this setting out, I should definitely write that I've used the product rule. Okay, if you use a rule, you should say that you've used it. Okay, now we're going to do a bit of tidying up. So we're going to get negative 2x squared minus 3x. What are we going to get here? Plus 20x plus 15 minus 4x squared minus 3x. Let's do our x squared term first. So minus 6x squared minus 3x plus 20x minus another 3x. So what's that? Plus 14x plus 15. Now again, this one you would have been better off expanding first and then differentiating, but just to show you how to use the product rule, at the moment I need to do these simple ones with you. So first thing times derivative of second thing plus second thing times derivative of first thing. Easy as that. This one, let's do the same thing, but in this case we're going to do function notation. So f dash x, first thing times derivative of second thing plus second thing times derivative of first thing. Product rule. So 2x cubed, what are we going to get here? We're going to get plus a 6x cubed minus a 3x squared. So putting our like terms together, 8x cubed minus 3x squared. Just to prove to you, let me do it in another colour though. You would have been way better off just expanding to start with. We would have got 2x to the 4th minus x cubed, wouldn't we, for our f of x. So f dash x is 2 times 4, which is 8x, drop that power by 1, minus 3x squared, which of course is the same as what we got using our product rule.